All right, ladies and gentlemen, so here we go. So we got some more complicated problems ahead of us. Now, this one's not as bad, but we need to take a look at what our bases are right now. So right now I have a base of 3 and a base of 1/3, and I want to write all of them so they are the same, but it has to maintain its equality. So if I have 1/3, well, 1/3 is the same thing as if I moved that up. 1/3 is equal to 3 to the negative 1. So remember, negative exponents are what we use when we end up with that reciprocal. So now I have 3 to the negative 1 raised to the x minus 2 equals 3 to the x. So I'm getting closer to the property that I want, so that I'm showing a base raised to a power equals the same base raised to another power. But here, I've got this negative 1 and the x minus 2 here. So before I can do that, what I'm going to do is to distribute that negative 1. So now I'm left with 3 to the x equals 3 to the negative x plus 2. And so now I'm down to a single base on the left, a single base on the right. They're the same one. So now I can drop the bases and just solve this equation. So if I have x equals negative x plus 2, I can add x to both sides. So x plus x is, you betcha, 2x. So 2x equals 2, so x equals 1. Now, we have a similar situation going on here. So I want you guys to pause this maybe and figure out what base you would try to make both 25 and 1/5. So how can we rewrite these as powers of our same number? I'm going to keep going, so you should pause it and see if you can get it, then unpause it and check your work. Now, hopefully you guys recognize that 25 and 1/5 are powers of 5. So 25 is 5 squared to the x plus 3, and 1/5 is 5 to the negative 1 raised to the 5 minus x. So now I need to be able to write this, simplify this exponent here. And so if I'm taking the power of a power, we multiply. So I need to distribute. So I have 5 to the 2x plus 6 equals 5. Again, I need to distribute to the negative 5 plus x. So I can drop my bases, and so when I drop my bases, then I'm left with the equation 2x plus 6 equals negative 5 plus x. So I'm left with x equals negative 11. Now, here we go. We're going to make it more complicated even. So, when we look at a problem like this, I've got variables in my exponents. So now, what I need to do is I need to look at my 4, my 8, and my 2, and I need to figure out how to rewrite those all so they are powers of the same number. Well, I'm pretty confident you guys know that 2, 4, and 8 can get rewritten as powers of 2. So this becomes, or stays, 2 to the x times, but now I've got this 4 here. Well, 4 is the same thing as having 2 to the second, and then 8 is the same thing as having 2 to the third. And then I need to include that x plus 1 on the outside. So as I'm including this x plus 1 here, This is telling me then that I need to distribute this. So this becomes 2 to the 3x plus 3. Well, now over here, I have the same base. But when I'm multiplying and I have the same base, what do we do with these exponents? I'm hoping you guys are saying you would add the exponents, because that would be correct. So I'm going to end up with 2 to the x plus 2. Because think about this right now. If I had given you guys a to the 5th times a to the 4th, you would rewrite that as a to the 9th. And so that's why we rewrote that, so that we could add those exponents and keep the same base. So I have a single base on the left, a single base on the right, same base, so now I can drop my bases and just solve the equation. X plus 2 equals 3x plus 3. So when I go ahead and do this, this leaves me with negative 2x equals 1. So x equals negative 1/2. So this one required us to rewrite the same bases, and I had to add these exponents to get it to a single base and then solve the equation. All right, and here's our last one. So when we go to do this one, actually I'm gonna make this one slightly more complicated. Okay, so we're gonna make that to the, so what I'm gonna do, I need to rewrite all of these so they have the same base. So when I go ahead to do that, I have 3, 1/3, 27. So I need to rewrite everything. Well, I'm hoping with a 3 and a 1/3, it's pretty obvious you're going to use a base 3. So I'm keeping the 3 to the 2x. If I have 1/3, that would be the same thing as having 3 to the negative 1 raised to the 5 minus 2x, and 27 is 3 cubed raised to the 2 minus x. Well, I can't drop my bases yet because I still have 2 of them here. I have these powers to powers, so we've got more work to do. So 3 to the 2x times 3 to the negative 5 plus 2x equals 3 to the 6 minus 3x. So now I need to condense this side. When you are multiplying and we have the same base, we're going to add our exponents. So I have 2x, whoops, I didn't mean to really do that. So we have 3 to the, well, 2x and 2x gives us 4x, minus 5, my husband yelling at my daughter, 6 minus 3x. And so then the last thing I'm going to do is drop my bases, and I have 4x minus 5 equals 6 minus 3x. So we have 7x equals 11, so x is going to equal 11/7. And yeah, answers can be fractions. You guys are going to see that. So notice there's a lot of manipulation going on here. I get that. But you know your properties of exponents, and you guys can look at the chart, or you guys can just do your best to rewrite all of these as the same base. But note, you cannot drop your bases until you have a single base raised to an exponent equals that same single base raised to that exponent. I hope this was helpful, and I will get a chat arranged for us soon. Bye, everyone.